going to do number 4 on the angular motion problems. We have, we're starting a lawnmower, and it says in order to start the lawnmower, the pulley must turn at 180 RPM. Now we know that's revolutions per minute. So what variable is this? It's angle over time, so that's a variable of omega, so that's a given. It also says that it has a radius is equal to 0.2 feet. So we're trying to pull start this lawnmower, and the first question says A, how many radians per second must the pulley turn? So we're looking for radians per second for the pulley to turn. Angle per time, well, that's just another unit for omega. So we're going to use this and just convert it to this new unit because we already know omega. So we're going to say 180 revolutions per minute, and we want it in radians per second. So we're going to say, all right, I want my revolutions to cancel. I want to have radians. 1 revolution equals 2 pi radians. So that's the way I write that conversion. And then I want it to be per second, so I want seconds on the bottom and minutes to cancel. 1 minute equals 60 seconds. So I always read my conversions over the fraction. 1 minute equals 60 seconds. Minutes on the top cancels minutes on the bottom. Revs on the bottom cancels revs on the top. When you do this in your calculator, this conversion leads to 6 pi radians per second. And if we get the decimal approximation of that, we have 18.85, so 18.8 radians per second. So that's the answer to part A. Part B says, how fast must it be pulled in feet per second? So for part B, we want how fast must it be pulled in feet per second? Well, look at the units, linear over time. So that's a measure of V. Okay, well, we're looking. We say we know omega, we know R, so there's an equation for V. V equals omega R. So the linear velocity is going to equal, well, which omega? It has to be in a radians unit to plug it into this equation. 18.8 radians per second times the radius, 0.2 feet. Feet times radians ends up as feet. The radians goes away, so we times that by 0.2, and we get 3.8 feet per second. So the speed that you have to pull that lawnmower to start it is 3.8 feet per second. And what is the angular velocity at the center of the pulley? Well, the angular velocity at any spot on the pulley is the same on the whole pulley. So the angular velocity is just going to be 18.8 radians per second. It's the same as it was. It doesn't matter where you are on the pulley.